today. Today's session will cover two categories for the openBIM Awards Program finalists. Design for infrastructure. Our finalists will be the China Railway Design Corporation, application of openBIM in the design and delivery of Guangzhou-Zhanjiang high-speed railway, presented by Feifei Zhao. And we will also hear from the category of design for buildings. The finalists in this category are Bond Bryan Digital, Department for Education, Gen 0, presented by Rob Jackson, and Statsbygg and AEC3 Deutschland, Lifecycle openBIM at Norwegian Viking Age Museum, presented by Steen Sunsen and Thomas Leibig. The session is scheduled to last approximately 1 hour and 30 minutes, with a short Q&A for the jury at the end. Now I would like to hand over to Feifei Zhao from China Railway Design Corporation for our first presentation.
Okay, good morning to you. And I am Feifei from China Railway Design Corporation. And today is my great honor to introduce this project on behalf of our team. The project's name is Application of openBIM in the Design and Delivery of Guangzhou-Zhanjiang High-Speed Railway. The railway is located in Guangdong Province, China, connecting Guangzhou and Zhanjiang City with a total length of 400 kilometers, a design speed of 350 kilometers per hour, 9 stations, 112 bridges, and 29 tunnels. The total investment is 77.7 billion Chinese yuan. It is a key large-scale transportation infrastructure in Guangdong, Hong Kong, Macau Bay Area. The project started on June 30, 2020, and will be completed in 16 months. The project's strategic objectives are developed from short-term, mid-term, and long-term. Short-term target is to improve the construction efficiency, quality, and safety of the project through the application of BIM technology in the whole process of design and construction. Midterm target is to realize the one model whole life cycle, digital application of all domains and all phases in design, construction, management, and operation. And the long-term target is to overcome the challenges of integrated application of BIM in railway design and construction, and to cultivate the ecology of BIM application in railway. The project stakeholders include the appointed parties, operator, general contractor, designer, and construction contractor. China Railway Design Corporation plays the roles of general contractor and designer. In this project, we developed a BEP based on ISO 19650 and openBIM standards to realize fully digital exchange of design information. We developed a couple of CDE for design and construction to meet the requirements of collaboration and to ensure that BIM data can be compatibly transferred to the construction phase and the construction management platform. We developed an IFC data review software to analyze and correct IFC files. In addition, based on BCF standard, we developed a software to capture and manage design issues, to realize collaborative review of BIM models from different parties and software platforms. The project adopted ISO 19650 information management process to carry out digital application from assessment and need to information model delivery. The appointing party firstly established the project's information requirements, delivery milestones, and information standards. This is our implementation developed based on the appointing party's requirements. We are now in 2022. That is the digital application in the design phase. We use the responsibility matrix to divide the responsibilities to ensure that each party can perform their duties properly. Based on the apporting parties' requirements, we have developed a detailed process map using BPM. First, the information requirements of the apporting party and appointed parties were defined, and a CDE was established as a data transfer center. All parties work around the needs of the apporting party. The apporting party entrusts the general contractor to be responsible for the implementation of the digital work. Focusing on the requirements of the apporting party, the general contractor developed a BEP for digital applications and coordinate the collaboration among appointed parties involved in the stages of design, construction, and completion delivery. The designer, entrusted by the general contractor, completes the digital design of the project, carry out digital applications such as design review, system integration, technical instruction, virtual reality, and design changes, and finally delivers the completed assets. And the entrustment of the general contractor, the construction contractor completes the construction index design based on the designer's model, collect digital applications such as steel structure optimization, panel shield segment layout, and construction organization arrangement, and finally delivers the completed construction assets. The operator is the final user of the project, responsible for receiving and inspecting the completed assets, and building a management platform to carry out asset operation and maintenance. We further established more specific information delivery plans and milestones as is shown in this table. To ensure appropriate implementation of the project plan, its domain involved in railway engineering were required to develop a BEP, such as a bridge, tunnel, and signal. We established a couple of CDE platforms for design and construction, respectively, as the data storage center. This is our ecosystem map. It is in line with the CDE. The design CDE is mainly based on Dassault 3D Experience platform, as well as some auxiliary design platforms, including AutoCAD, RDS, and Revit. Model compliance check platforms include IFC Reviewer, BIM-based and Navisworks. The construction application platforms mainly include Dassault, Delmia, Tekla, Composer, and Supermap. The 3D Experience Innovia was used as the design CDE, and BIM standards such as IFC spec and the CR-BIM classification and coding standard were applied in this platform. RDS developed based on AutoCAD was used for the design of client, which was output and exchanged to CATIA through the IFC Alignment 1.1 standard. CATIA was used for the design of subgrade, bridge, tunnel, and track. Revit was used for electromechanical and architectural design. IFC spec standard file was used for data transfer between CATIA and Revit. The information model was finally delivered in IFC files. IFC spec standard and the CR-BIM standard were deployed in 3D Experience and used to create information models by different domains, and they also can add some property sets to the model. Based on IDM framework, OpenBIM was used to express the collaborative design process of railway engineering. They exchange information requirements, that is ER, between different domains were clarified, and the exchange requirements were mapped to the information container to realize the exchange of design information. Based on the process map, we were able to carry out engineering design level by level according to the application objective. First, we established models of LOD 1 to 2 level, and further create models of LOD 3 level, mainly used for detailed design. In order to carry out construction applications, we implemented LOD 4 level detailed design in complex engineering, such as reinforcement design, steel structure design, panel segment arrangement, and station design. Based on the BCF standard, we developed a software to capture and manage design issues. The reviewers can capture and record the design issues, and the relevant parties can directly locate the issues in the model and solve them, realizing collaborative design checking by multiple parties and platforms. This is a typical model checking issue through BCF. The reviewer found that the design of the subgrade retaining wall was insufficient, and the designer made some modification based on the reviewer's comments to make the subgrade retaining wall correct. After completing the creation and modification of the information model, before delivery, the data compliance check was carried out using our self-developed serial reviewer software. After the data was checked and improved, the FC data was submitted to other parties for some other applications. Other parties use the construction CDE as the data transfer center to deliver BIM data to UE, Delmia, Tekla, Composer, and other software. A VR system was developed to connect with the HTC Vive headset to get an excellent immersive experience. Through dynamic simulation of the bridge construction process, it can provide the construction workers with more intuitive understanding of the railway construction process. We carry out refined design of reinforcement bars, implement detailed design of LOD 400 at complex nodes, and assist the construction workers to construct according to the model. By referring to the 3D specification of mechanical products, we use Composer and 3D PDF to develop the 3D design specification of railway so as to realize the 3D technical instruction and information model delivery. The next part is mainly about the use cases. I will briefly introduce some use cases. The first use case is the comprehensive pipeline collision detection and optimization. Based on the BCF theory, we carry out multidisciplinary pipeline design checking and optimization to help improve the design quality. The second use case, based on the land XML MVD, we developed a tool to convert BIM data to land XML, extract the required subgrade construction parameters, and import them into Trimble Business Center, HCE, to realize the transfer of BIM data to the construction machinery. The third use case, based on Unreal Engine, The carbon CDE was still used for data exchange to complete the data transfer from design to construction and realize the high-quality visualization of large-scale railway engineering. The last use case is to establish a tunnel construction management platform based on GIS technology, and IFC files were used for data exchange between the BIM design software and GIS system. The last page is about the key participants and the contact information of this project. If necessary, please contact us. Okay, that's all for my presentation. Thank you.
Are there any questions from the jury? Yeah.
Hello, can you hear me?
Yes.
Yes, you can hear me. Yes. Just for clarification, maybe I misunderstood, but what did you exactly mean by the two level CDE platforms? Is it one for collaboration, one for integration, or did you mean something else?
Yes, the two CDE is one is for the design and the other is for the construction. The design CDE.
Yes, for two different phases. Okay, thank you. I get it. Yeah.
Thank you.
Perfect, thank you. We'll move on to the next category of design for buildings. The first presentation in that category will be from Bond Bryan Digital, Department for Education, Gen Zero, presented by Rob Jackson.
Yeah, thank you for the opportunity to present this case study for Gen Zero, which is a case study for the Department for Education in the UK. The project was a research and development project looking at the design and affordability of carbon zero schools. It involved the design of two theoretical schools, one on an urban site and one on a rural site, and involved the RABA stages 0 to 4. So only design stages was the original scope of the project. There are 7 different disciplines involved in the delivery of the project in terms of modelling disciplines, and the delivery team was led by Mark MacDonald. The whole project has been built around ISO 19650 and information management, but was really exploring a lot of R&D aspects of this project, and was really designed to ultimately inform future Department for Education projects. Now, when we originally got the brief for this project, we were given these 4 themes: sustainability, standardization of spaces, technology and design for operations, and BIM and digital, along with the ISO 19650 process, was placed under technology, along with the need to provide Autodesk Revit models, a link to MBS Chorus and use a common data environment. But we quickly realized that actually many of the themes across all of these 4 themes that BIM and a digital delivery could deliver. So we quickly revised this brief and came up with effectively a fifth stream, which is information management. So we separated information management out of the technology section and created its own sort of process. But we also wanted to importantly embrace an agnostic approach to the project in terms of openBIM. And this was before any designers were appointed. So we had an opportunity, I think we had 10 days to write the brief for the project. And we wanted to look at as many aspects within the time available to try and cover all the 4 themes that we've been set out, and plus this 5th theme. So I'm just going to run through the different aspects of the brief to kind of explain it. So information management was core to what we do. That's what we were employed on this project. And we followed the ISO 19650 Part 2 process, probably the closest of any projects we've delivered over the last 3-4 years since the standard came out, where all our projects are following this, probably the most truthful to this process in terms of assessment and need and going through the invitation to tender process and tender response and so on. And what we ended up with is a team where the DFE are the client or the appointing party, and Mark McDonald are leading the delivery team with the various designers appointed under them. We were paid initially and employed by the DFE, and then we were actually moved to the contractor side. And unusually, we're effectively the information manager almost across both. So we had a relationship both with the client and the delivery team, which actually definitely benefited the project and would definitely be applicable to other projects going forwards. So we wrote the brief. We set the brief out using what we call our information hub. It's a platform of a number of technologies. So we wrote our documentation using a platform called Notion to set out all of the information requirements. And you can see here, it's based fully around the ISO 19650 Part 2 process. You can produce PDF versions of it for contract, but you can also view these on mobile as well. So this is something we've been working on for some other projects. But behind all of this, there's a database of tables, various tables and views of those tables. And the vast majority have been developed around open standards. So using IFC as the core to a lot of the exchange information requirements, particularly around the model data and the geometrical requirements. And we've been developing this process through a number of projects, but we really got to implement a lot of this on this particular aspect. And what that ends up being is a series of these table views. So this is showing you the entities and enumerations, showing you some of the settings in the IFC, but there's a whole series of these tables setting everything out from naming. So this is a naming example where we set out the type name that we want to be provided by the designers, and also the occurrence naming, which in Kobe ends up in the component sheet. So this is all defined and set out before the project begins, so the designers know exactly what they're signing up to. We also set out all of the information about when it was required and how it's going to be delivered, and even some of the predefined types we insisted on making sure that as a minimum we had user defined, although obviously we were trying to make sure that the enumerations and predefined types were correctly set within the project. And all of these tables are embedded directly back into the documentation. So instead of just having a Word document, which then becomes a PDF and Excel, these tables are actually embedded directly within the database so that they can see all of these requirements. So that was the kind of information management side. The second side of this is technology. Technology to us sort of sits on top of the information layer. So the information layer comes first, but obviously these models are important. So we federated models for both the buildings, so both the urban and the rural site, using Solibri as our primary tool. Obviously, they are three-dimensional models and they look nice. The architects produced visualizations, as well as the landscape architect actually producing some of the visualizations for the project. These were from the architect themselves of cut-throughs of the various the model, and obviously these were very valuable to the client in understanding the design, and the design was an important part. Bear in mind, most of the client at the DFE are actually architects themselves. But we also wanted to explore other technologies that we weren't necessarily using on the project. So this was using 3D Repo, which is a cloud-based platform to share the model. We certainly discovered some issues with using the platform, and we fed a lot of their comments back on the IFC process to them. But you can see on the right some of the data associated to some of the spaces, which again was all specified at the outset. So we tried to use this process just to see how we could share the models with the client. Again, those models were embedded back into our information hub or into our platform, so the client didn't actually have to go off and find 3D Repo. They could just go into the documents and find this information. So that's why we typically call them resources like the ISO 19650 process. The other thing was, as I mentioned earlier on, is the DFE's expectation was that everyone would use the same software. But they obviously wanted to employ the right designers for the process. And in going through that, we actually ended up with designers using Graphisoft ArchiCAD, Autodesk Revit, Bentley ACO Sim Building Designer, and also Nemetschek Vectorworks for the landscape as well. So we had 4 different authoring tools across 2 different buildings. So we had 14 different models using a variety of models to incorporate that. And that was only really possible because we'd written the requirements around open standards from the very outset. So we hadn't eliminated anyone going into this process. I think the video you had up before was probably talking about this, but this is effectively the software diagram that we ended up with. There were a couple of native models uploaded to the common data environment, more by accident than by desire. But actually, even the Revit users were using the IFC models from each other to upload and share between themselves through the common data environment, which in this case was a site. The models were downloaded by the architect to federate those in BIM Collab Zoom. They were using that to do the coordination process, although they were fairly green and new to this process. the cost consultant was downloading it and using those in i2 Costex. And then the models, we were downloading those into and using them in Solibri to produce a COBie output. But we were also using Solibri as an intermediary to get the data into one-click LCA to do the carbon analysis. We also then developed a workflow to link specification data, because we found that some designers were struggling with the Chorus interface. So we actually created a free way of linking models back to our platform. But all through this process, what we were trying to do is make sure all of our models were consistent across, all of these disciplines, irrespective of which software they come from. The primary difference is the architecture model contains the spatial and zone information, but all of the others, the structure, the data of this is identical. So in our information hub, as an example, we set out the site name, what the site name has to be, not just the fact that we want it. In this case, we wanted it rural. So we've got 7 different models all providing that data consistently. And this applies as well to building and site and so on, getting those consistency. And what we end up with is a huge, vast amount of data across all of these different disciplines, which you wouldn't know where these models had come from. They've all come from different sources, but the data that we've asked for, the structure of the data is all consistent across these models. And so we end up with a schedule of data, and we ended up with NRM, some of the NRM data. We also generated data from other data using Solibri. So we supplemented it with some additional data by using mapping. But you can see here consistency of naming, uniclass classification. We also had all the Chorus, MBS specification Chorus data within the models to create this consistency to allow us to provide this information to whoever needed it through this process. And we supported all of this through a model checking process using Solibri, using a library of rules. So this was a standardized library that we've built across lots of projects that we can then supplement with project-specific rules. And to give you an example, so these are some of the project-specific ones. We actually added a whole ton of data. I'll come back to this on the building. So this is checking the phase of education has one of the acceptable values. Of course, all of this was published at the beginning to say what these acceptable values were. So we're going through the checking process to make sure the model data was being provided. All of this with a backdrop of a design project that was evolving R&D-wise from a carbon perspective. So we were fighting the design all the way through it, and we're still trying to deliver this data. Equally, when I talked about linking to the specification, the beauty of this is the IFC models can be opened up in any software, and the URL that you click on, we were using this in Solibri, but you can click and it takes you directly to that clause, not even just to the page, but to the exact clause that you can find this model in, so you can go and download and upload and view them. But we can go and this is just an example, but you can go and open the same model in BIM Collab Zoom or any viewer that you want to. Click on the URL and it'll take you to the spec. So we're trying to demonstrate to the client that this process could work, and actually it didn't even need to be MBS Chorus, which they'd specified at the beginning. The third stream of the brief was around standardization of spaces. So we were given a list of codes that the Department for Education uses to specify all of their rooms, and this comes in an Excel document. And what they try and produce, or what they ask you to produce, is an Excel document of every single room where this orangey peachy color is their requirement and the gray is the delivered data that you have to fill in. They do this through an Excel process currently, and we were looking for a different workflow to try and demonstrate how this workflow could work. So we actually managed to again, we specified all the data. So this is the specification of that data that we required to deliver those outputs. So we went through a big process of specifying all the fields of information built on top of IFC and COBie to supplement with the information the client specifically needed, including the names of the properties, the property set, the values that could be used. And we went through a process as well of mapping this to standard classification systems. So the classification reference, both uniclass and activities, was considered through this process. We actually identified a number of holes which were fixed by MBS post this project. We also considered the zoning of these spaces and how this should be done consistently. I'll come back to this as well in terms of how that's important. But all of this standardization of data allowed us to also standardize even the coloring up of this data within the models. So this classification reference that the DFE uses, we provided consistently across all of the models so that they could go and isolate any of the rooms. So you can go and look at all the classrooms by simply clicking on that. The color of these using this orange color matches with the orange color in their area data sheets as well. So we're really trying to think about structured data that was in the Department for Education's how they want to look at data and how we would consider that information through this process. You can also look at that, of course, using a schedule and look at those spaces in 3 dimensions as well through a similar process. And all through this process, we were building processes even during the project to try and work through this. So we had an ArchiCAD user creating spatial data that then needed to be supplemented with M&E data, and we used IFC to pass between the ArchiCAD and the Revit models to collect data and then pass it back, and then this whole process ends up in us extracting this data into an Airtable, which is an online sort of combination of Excel and database to be able to produce a room data sheet. So this is what the data looks like in the ArchiCAD model. So this was all natively done, but obviously came out in exactly the places we wanted it to in the IFC model. This was then a data sheet or a schedule that was created to share with the other designer to basically populate back into the IFC model so they could see all of the data once it had been returned. And what we were able to do at the end of all of this was produce from using IFC, so all this data came via IFC or was automatically effectively generated from a database or mapped from the database. We were able to generate these data sheets for all of the rooms, so there's hundreds of these rooms, with both the orangey peach color as the requirement and the gray as the actual delivered data against this. It wasn't perfect, but we certainly had a damn good go at trying to use IFC as the mechanism for this whole process. And again, those data sheets and the data were embedded back in our platform so that the client could effectively access all this information without needing to go and find this somewhere else. And we created a number of these data sheets, not just the spatial data sheets. We had data sheets basically demonstrating all of the data that we could extract from the model. Some of these are earlier screenshots and some of the product data ones were populated later, but this whole process of extracting data into effectively a table to then display as a human readable output was an important part of this process. The fourth component is the sustainability component. So carbon assessment was important. So obviously that was one of the key things. Can you afford it and can you get to carbon zero? So we used One Click LCA was the tool that we had to use through this process. And we went via Solibri into an Excel spreadsheet and into One Click LCA. A lot of work to make this work, a lot of thinking in terms of using IFC data and not asking the designers to provide some of that data. So One Click LCA uses its own classification system. We didn't ask the designers to put that in. We used Solibri as an intermediary using some of the IFC data to generate that. So, for example, in this case, boiler type actually becomes building tech is the classification. So we're using Solibri as the intermediary to make this process work. And equally, we were concatenating some of that data because One Click only has so many fields it will import. So we're using some of the data we already had to make this process work. What that allowed us to do is generate a number of schedules within Solibri, generate this as an Excel export. So this was what we actually got out of the Solibri model. You can see here all the quantities associated with all these different products. And then that data was imported into One Click LCA to do the carbon analysis process. Now, originally, this was supposed to be a direct from the authoring tools. We wanted to demonstrate that this could be replicated across using, whatever authoring tool you bring to the table. And obviously, from that process, the carbon assessor was able to do all kinds of assessments on the data that we provided and provide a result. Alongside that, we needed to know whether we could afford the building. So at the beginning of this process, we worked with the cost consultant to identify the costs that they would need. We tried to use the data that we would already have, so some of the Kobe nominal dimensions and size information, and then supplement that with base quantity information to make sure that we could provide what we needed. And that information formed the basis of the models being extracted using CostX to use the data and the naming conventions and so on to produce the cost report that ultimately was produced at the end of the project. The final aspect is design for operations. And this basically was us generating Kobe from the IFC models that were brought together in Solibri, using the free Kobe QC reporter, and also bringing this data back into Airtable, into the database as well. We created quite an interesting Kobe workflow for this. So we actually, the red stuff you see in the middle is actually the briefing information from the client, and the blue stuff on the right is all the additional, and it goes on a lot of columns of data that we extracted from these models. We are able to bring this into the Airtable database, largely through copy-paste, although you could probably use an API to do this process. And then you're able to filter and cut and carve this information. So this is the data by the unit class, all the rooms by unit class data. But then you can also graphically represent this data once you've got it into a database. So you can go and click on this. This is a whole live interactive dashboard. And then the clever bit, I suppose, was that we were also, as part of this process of connecting brief to IFC, was what we were trying to do was collect data that the client wanted. So on the left is a website. This is the website that it's a draft, a beta version of a website about information for schools. This is where we collected the requirement from. The blue sheet in the middle is effectively all the data that was being collected from the model directly from the IFC and displayed as a data sheet so that the client could understand the information. So we created a fairly simple workflow to allow that to happen. Just some final thoughts. Obviously, lots and lots and lots of lessons learned on this project, both positive and some negative as well, but mostly positive, demonstrating that IFC works, that it works for many purposes. It requires some effort, of course, to be able to make that work, but we could standardize this process throughout, and we successfully delivered the Stage 4 project with the other consultants. Of course, we're not just the only ones in this process, but eventually this actually ended up being a physical build. So they actually built some of the classrooms for COP26 for the carbon, demonstrating the carbon workflow in reality. So these would be actual schools that would eventually be built, and we started doing these, and they're now looking at whether they could take this design further. And probably the most important thing from the back of this project, which ended up being, I think it was 9 or 12 months, is that through this process, we also then produced all of their documentation for the Department for Education's framework, which is a £7 billion framework lasting the next 5 years. So this is now fully integrated into all of the Department for Education's projects, not all of the aspects, not all of the data, but the fundamental approach of specifying data around IFC and also including COBE as well, and open standards is fully built into a major government department, through this project. And then that's me done.
Thank you, Rob. That was an excellent presentation. We're now just going to hand over to the second presenter for Design for Buildings, and then we'll move to the Q&A at the end of their presentation. So
okay,
you don't mind just hanging on the backstage for a while?
That's fine. Thank you.
Thank you. Perfect. So now we will be moving to Steisberg and AEC3 Deutschland, Lifecycle openBIM of Norwegian Viking Age Museum, presented by Steen Sunsen, who will be online, and Thomas Leibeck, who is in the room.
Yeah, and I should start.
Okay.
Can you then open the presentation?
Yes.
And I hope that Sven and Omar is online in Oslo. Okay, then I start from here. So welcome to our presentation. It's between Statsbygg in Norway, and Sven and Omar are sitting in Oslo right now, and AEC3, we're actually from Munich, and I got the opportunity to do here. Maybe next slide. We started, make a very brief introduction who we are. So we have been quite engaged in all buildingSMART and openBIM project from the beginning of IAI, so that was back in 1996, and also involved in IFC development from the very beginning, but not only in the development, but also trying to use it in projects. So we are consultants, we help clients, and Statsbygg is probably one of the most innovative clients we have worked with, and that all started already 12 years ago in 1910. That was the first international architecture competition where IFC models were obligatory to send in. That was 12 years ago, and that was quite a challenge at that time. But we succeeded. We got over 200 entries in the first round and 6 in the second round, and that was all based on openBIM already 12 years ago. But of course, we want to go further, and one of our main topics is information management, information requirement management, and quality. And we are using a lot of buildingSMART standards like IDM, how to develop information requirements, MVD or now IDS, how to state it and validate it, or of course BCF to communicate the changes and so on. And maybe the next slide. And in order to implement it in projects, we have created also an own cloud-based system that handles the whole workflow of information requirements. We are adapting this plan, do, check, act principle. And when you state the requirements, then you execute them, you verify, and then you learn in a continuous learning environment, continuous learning cycle. And so this is also used in many buildingSMART projects like rail and road and so on. Some of you know it for MBD development, but also in projects like the projects and the Viking ship museum. And of course, we're also looking not only into buildingSMART standards, but of course also what's happening in ISO 9650 is clear, but also 17412. For those, this is a standard that handles all the LODs nowadays as an international standard, how court the level of information needs. And of course, a dictionary standard that handles things like ECD and other standards interconnect. Okay, the next, please. Okay, that is a little short look into the BIMQ cloud. You can see here that the Startsbook implementation or server, and it has the Startsbook information requirements. It's also a national standard there. Simba, I think probably Stan will say more about it. You have the elements, the domains, like what belongs to an architect, to a structural engineer, and so on. And you have it with complete IFC mapping, so you can derive MBD or IDS to verify the MBD, the IFC files. And on the second side, you see all the data drops where information has to be delivered to the client. Here starts back, and you can see what subset of information has to be there, and then you can do a gradual check from the beginning throughout the whole project whether all the information is actually there as required. Next. And this, then can you remember these colors from the plan, do, check, act principle? That's the same here in this Startspeak project. On the planning part, this little bit or beige color, that's where you set the project-specific requirements, and you will see Viking ships. So some properties for Viking ships are not necessary for all projects, I guess. So you have a little bit specific. You send it over to the designers, to the contractors, and so on to utilize it. That is the doing part. They will deliver the IFC models to the client for various verifications, and I think Stan will show this. And here you have the check part, and this check part is currently using automatically generated checking rules from this project-specific requirements. In the moment, it's MBD XML, it will soon be IDS, so you can have this automatic cycle, and the green one goes back, the lessons learned. Whenever you learn and you want to improve your information requirements, it can go back in the basic Startsbook database for all projects and can be provided for the next project then as a starting point to be project specific. So at this point, I think, Stan, I give it back to Oslo. Please continue.
Thank you. Oslo here speaking. You still hear me?
Yes, we hear you.
Good. And this procedure, as Thomas has showed you, this is a foundation in all our projects. So, good morning, everyone. My name is Sten Sunesen. I'm leader of Startspeak's BIM group and also of the development of our BIM requirements. The methodology that Thomas has showed you for just both requiring very specific openBIM on common information standard and also to follow up deliverables with automated model check is the foundation for all our value-added BIM process that I'm going to show you now in one of our projects. First of all, to give you just a brief introduction to Startspeak. Startspeak, we are the Norwegian government's building consultant, client, owner, and operator, and thereby we represent the entire building lifecycle. We provide workspaces for many of the government's different organizations, not typically buildings that are available in the commercial market, such as office buildings, but we build and also operate courthouses, police stations, universities, and national opera, as you see here in the picture, and also museums. In Startspeak, regardless of our different functions. All employees make decisions based on information. So access to information is crucial for us to make the right decisions and to achieve our strategic goals. One of our most important strategic goals these years is our development towards sustainability. And we need correct and updated information and to know if we are building the right buildings and also if we are building them right. The most sustainable building is the building that you don't build. So digitalization in general is important for us to make information both searchable and machine interpretable. openBIM is a central part of our development towards digitalization. And BIM on open standards is the foundation both for sound competition, innovation of services and softwares, and also much better suited for long-term storage than proprietary formats. So Statsbygg has required use of openBIM actually in all our projects since way back to 2011. We have also supported buildingSMART from early 2000. And we participate in this award to create awareness of our openBIM methodology that we have developed together with AC3 Deutschland. The Viking Age Museum is a very successful example of implementation of our BIM requirements. The Norwegian Viking ships and all the other Viking Age artifacts are very important to Norwegians. They are regarded as our crown jewels. It's a part of our identity. So this is a high-profile building, not so big, but with a lot of focus. The new Viking Age Museum is an addition to the existing museum that is relatively old, 100 years, and it addresses needs simply for increased visitor capacity and also modern educational facilities. In the following pages, and this is just an overview, I will explain the main value-adding processes once the model information is quality assured, as Thomas explained to you. In this project, the Viking Age Museum, it was chosen to focus on the following 4 processes. And the first one is to make important information and analysis available for the project management. The second one is to have continuous cost estimation of revised models during the whole design stage for design to cost. The third process, and this is the very important part of this project, is to safeguard the Viking ships. You need to understand that when the Viking ships were excavated more than 100 years ago, the conservation technology was not as developed as it is today, so the Viking ships, they are very fragile. The location of the museum, for example, was simply chosen to reduce transport of the Viking ship. Otherwise, we probably would have put it more in central Oslo. We utilize openBIM in this project to visualize and simulate both the protection of the Viking ships during construction and also to have a safe transportation of the Viking ship into the new building once it's finished. And the fourth process aims to achieve a seamless handover from the turnkey contractor of the model to Statsbygg's building operation. And this is mainly done by following up that deliverables are according to our common information standard. So the first is to make the first process to make the information available, and we have landed on a solution that we call Project Dashboard. And we experienced that it's important to get project management on board and get them committed to openBIM. So we wanted to offer them something where they could actually have a direct value from openBIM. And also it is a very strong tool that will really improve the project performance. So the Project Dashboard provides important management information from updated models and other sources. This makes information easily available for all project participants, not just the project management. And we're using Power BI and VCAD, simply available from Microsoft Team Channel that is provided to all projects in Statsbygg. This is our main platform. The dashboard provides low threshold and dynamic data. It doesn't require any login or anything. Everything is good to go and works for everyone. And it's easy to adapt to different users' needs. The project dashboard to the right, which in this openBIM connection is probably more interesting, is utilizing openBIM information. Models are updated weekly using robotic process automation, and all projects in Statsbygg can actually use this with no extra setup needed. So simply by changing the IFC path in the VCAD portal. And this is possible because we use a common information standard across all projects and have a quality assurance technology and methodology together with the AC3. And the information that you see is something as simple as we have a maturity index code saying how far developed an object is matured. And also we can see how many objects that are available on the different sections of the building. So that is actually give very good input. The next one is to have a continuous cost estimation during the design. So you actually at design make design to cost. And the cost analysis tool in this project is a Norwegian tool called Easy Calculus, and that is an expert tool. This uses openBIM for both quantity takeoff and automatic identification of both objects and types. And this saves a lot of time and also increase accuracy of the cost estimation. The cost estimation is updated monthly because it's a bit more heavy process and during the design stage. An important feature of this is that it also provides analysis both for LCC, life cycle cost, and for the CO2 footprint of the specific chosen material. So the designers and contractors can thereby optimize the material's environmental impact together with assessing the cost. And the project's turnkey contractor emphasize the importance to work disciplined and standardized with openBIM in order to achieve this efficient work with cost analysis. They say that Statsbygg and AC3 methodology support this. And I just want to read the highlighted part in red, that using BIM for easy quantity takeoff and identification reduced time for first iteration of the cost analysis from approximately 3 weeks to 3 days. So massive amount of time is actually reduced. Simultaneously, it increases the certainty of the code. They also say that the continuous cost estimation based on new model version as the project developed is simply not feasible without openBIM. And this reduced the risk for the contractor, resulting in both improved competitiveness for the contractor and lower cost for the client. Cost analysis is also made available for all project participants and specifically for the project management in the dashboard. And this is important because, as I said, it was an expert tool, but then you can actually transfer the information once the cost has been estimated and making it available. So information is made available also using Power BI in the team channel. Information is dynamic and are grouped by parent-child principle, so you can look up more detailed information simply by clicking on a cost you want to know something more about. It also tracks development of cost from earlier cost estimation, so you can see how cost has developed in the project month by month. Then the transportation of the Viking ships. This is an exceptional use case specific to the Viking Age Museum. We don't have many others with this need, but it demonstrates the innovative power of openBIM simply by using information that is there, or at least technology is already there. The project has modeled both the ships and the steel jigs for safe transportation of the ships, and also the transportation route. The transportation route is modeled as in space. Everything is IFC here. And then we use clash detection between the Viking ship transport route and other building components from the ship's current positions to its final location. The project uses on-site augmented reality visualization of the transportation. And by simulating the Viking ship's movement inside and along the transportation route, we can simulate the moving operation for workers involved in the transportation, and we do it on site. Because of the high quality of the model, the turnkey contractor AF group can compare laser scans with the model. So during the design stage, they're using the design model and compare with scans of the existing buildings. And that's to make sure that the design is based on the present situation. Then moving to the construction stage, which just has started this year, they are now starting to scan the work that has been done and compare that with the design model, and to make sure that the work is done right. As I mentioned earlier, Stadsbygg, we represent the entire life cycle, and therefore we also need to have a life cycle approach to information management. And we want to operate and facilitate our buildings efficiently and standardized. Information shall be available from multiple platforms regardless of the users and independently of which project has provided the information. This requires that all information shall be uniformly structured across all projects. And the common information standard and model check methodology provided by our database supports this. This leads us to the final process, the model handover. Since the project delivery according to Stadsbygg information, it makes it easy, or at least much easier, to achieve a seamless model handover. And a part of the handover process links openBIM information to other information such as documentation. And this linking is again somewhat automated because both objects in the model and documentation have a similar coding with a Norwegian identification system based on an ISO standard. The geometrical model provides an intuitive way to navigate the project and easily look up information. It's relatively new to us to use models for building operation, but we see a potential to have both easy access to information regardless of where you are, also on site, and also to be able to do central planning or even outsourcing services and maintenance. And this is a standard procedure applicable to all our projects. So finally, about our openBIM learnings, what we have learned so far in the last 15 years is that openBIM is absolutely necessary, and it is also possible. openBIM is a condition to successful digitalization of lifecycle information. It requires collaboration, learning, and discipline. It requires investments, and it also requires a lot of patience, because openBIM actually changes the way the industry collaborates. Stadsbygg has no doubt that integration of openBIM into project execution and operation of buildings is the way forward. In Stadsbygg, we will continue to invest in openBIM because we believe that cost of development will be covered by savings in the longer run. We hope that our finalist position in this award will help us to reach out to other clients and raise the awareness of the opportunities. Many thanks.
Thank you very much. We'll now just invite, if you can stay up if you,
Yeah,
we're going to go to Q&A, so I'll just bring Rob back on. And if there are any questions from any of the jury members, now is the time.
This question is for Rob. Can you hear me, Rob?
Yeah.
So earlier in your slide, I think you had showed, one of your earlier slides showed the requirements, I think were all Revit, and what you were delivering was openBIM, IFC stems. I think at the end you had said that you were convincing the Department of Education to make openBIM the standard. Did I hear you correctly at the end?
Yeah, so the original requirement or the assumption was that it would all be one authoring tool, largely because it was meant to be a 6-month project, and they felt that the easiest way to get from A to B was all use the same tools, which I could sort of understand, but we didn't know who the consultants were going to be, and as it turned out, they all wanted to use different authoring tools. So we'd already preempted that, and when they said, we've got a designer who uses ArchiCAD, is that a problem? No, I've used ArchiCAD for 20 years. We've got a Vectorworks user. I've come across that before. We can help them. Bentley I hadn't used before. But yeah, by the end of the project, we had convinced the Department for Education through the project that it does work to generate different information based on purposes. And what that allowed us to do is write new information requirements, which are now across their whole framework, all built around open standards, which we're now actually delivering. I think we're working on about 6 schools now, delivering those with different designers, using different tools, even more tools than that, Tekla and so on, to deliver those requirements in line with the client's aspirations.
Another one for Thomas.
Yeah.
On your project,
Yeah.
what are some? I'm really intrigued by the closed loop of bringing lessons learned back into the Statsbyg's requirements. Can you give some examples of what some of those lessons learned might be?
Or maybe I can start, but maybe Stan can probably then step in.
Okay.
I mean, what I have shown there is we are here about information management and handling of information. And in every project, you learn what is actually required and what might be superfluous. And 9650 says LUEN is there to prevent too much information because that's waste. So you can learn from the cycle. So maybe if something has not been used, then tick it off. If it has been used, or required, that was not there yet. But maybe Stan can say more from Oslo.
I'm sorry, it was a bit difficult to hear the question, so would it be possible for Thomas to repeat it?
The question was really about the cycle of bringing the lessons learned from the process back into your standards and Statsbyg's requirements. Like I was asking if there were some examples of some of those lessons learned going into the future.
Yeah, well, you can say we have a learning process simply by actually looking at the log, change log from different projects, where we can gather changes made in the specific projects and see. But also, we are the same group who are developing the requirement. It's the same group that is developing this requirement set on an annual basis. And we have continuous talks about experiences from projects. So we don't have so much a formal structure of how we're doing it because it's a relatively small group working in all the projects and getting the feedback. But learning is very important, no doubt about that. And also when we see that typically there are some pain points that we need to raise to higher level. For example, something about the quality of IXC exports from some softwares. We need to discuss that with the industry, and we have actually recently had several work sessions, workshops with both vendors and the industry as such, and so on, to really dig into some of the pain points that we experience in several projects. I don't know if that answered your question.
Yeah, it kind of does. I'm also intrigued. It probably probably doesn't have much to do with openBIM, but like you mentioned on one of your slides about building right, doing the right buildings and then building them right. Does any of this take into account the technical aspect of the actual structure, the sustainability, constructability? Are those kinds of lesson learned within your domain and this system? And if so, is there any different way that you track them, or is that kind of?
Well, I think it's if you work with model based and in general the right information, robust information, and you have better process for decision making, it's easier for us to actually achieve the overall strategic goals, for example, for sustainability. And we also try to drag in the experience that we have from project design into early stages decision making and see how little information can you use and often actually reuse, because now we also are starting to see a portfolio of digitized existing buildings, and how can you reuse that information in order to make better assessments of, can this project actually be used for the need of our customers from the government, or do they really need a new building? So we are trying to reuse as much as possible. And this is a change in how we work together with our customers. we have been very happy to build new all the time, and we're actually changing our focus to reuse the buildings, and we need to get very good information in early stages in order to do that.
Thank you. Can you use the mic?
Yes,
I'm sorry.
I will bring it around.
I could walk this way.
There you go.
I have a question for both candidates. So, and how easy would it be for you to reuse the methodology you just demonstrated for other projects? So, what is reusable? What is handmade for the next project? For both of you, please.
Who's going first? Shall I go first?
Well, Brian, you were first, so you can answer first. So it's okay. If you want to, otherwise I can take it. Yeah.
Yeah, that's all right. I'll go first. To be honest, the process that we're using the platform to set out information requirements, to the Solibri process of rule checking, generating those IFCs in a consistent way is across every single project that we do. The only difference here is that this has more use cases, more purposes, I guess, to what we're doing. So what we've been trying to do is take this process and refine it. Now, the interesting bit is that if you take the information requirements, for example, we recently got onto another project for the Ministry of Justice, and those requirements are actually built in a different platform, but the fundamental data structure that we built around IFC and those processes still works. So it doesn't really, the technology isn't what's actually dictating, it's the approach to open standards, which we've basically built our whole business over for the last, well, certainly the last 6 years, and even before that, I could go back to 2007, I think, when we started it. Probably not as long as Thomas and Steen, but we certainly are trying to improve on those processes. So we, like Thomas mentioned, you learn from these projects and you throw away stuff that you think, it probably wasn't worth it, and you add accordingly and you amend it. What I would say is that what we've just done for this project, then the Department for Education, we took to the Ministry of Justice. We're now doing it on residential projects across a number of clients. And most of the requirements are very similar, in truth, because most of them want us to do the same things. And we keep refining that process and learning from one project to the next.
Okay. For our part, if you remember the picture of the database from AC3 that we use, on the left side, you had what we call the information standard. And that means that information is structured uniformly regardless of all our projects. And actually, we're in the process now of also sharing it with other client organizations in Norway, and also have dialogue on Nordic level. So we try to harmonize as much as possible. And of course, IFC is the foundation, but then we have some local classification and rules and so on, how we implement it. But those are common for all projects. And then on the right side, you had Statsbyg's project model that is unique to Statsbyg, but is still applicable to all our projects. And then you had these crosses, meaning if we actually are requiring this information in this milestone, and that can differ from project to project. So I would say that many of the information that we require, of course, reflects what are you going to use, which value-adding processes, BIM-supported processes, are you going to execute in the specific projects. So we scale up or scale down according to the project needs. This is a manual process now, but we are having discussions with AC3 to how we can more automate it on a higher level. So simply by addressing that we want information for, let's say, energy analysis, then it automatically provides the information and the crosses along the milestones for which information to be delivered at what stage. So our aim here is to have as robust a solution, and our goal here also to have an SME approach, small, medium-sized enterprise. So we're not leaving small companies behind. The majority of the Norwegian industry is SMEs. So this is an important approach to us as well.
Just to add to Stan, I mean, what we are trying to do is we're trying to modularize these basic requirements in a way, like, for example, tagging it to use cases, like you said with energy. And then if you choose a new project and you know what use cases you actually want to do in your new project, you get a suggestion of information requirements. because you get all those that are actually tagged to the use cases you want to use. I mean, it's a difficult process. It's not without manual intervention and so on. You need a lot of engineering knowledge for this. I mean, that's also important how we can engage all the engineers on that, because they know, not necessarily we. But I think that's probably the way to go, to modularize it and adapt it into new projects.
Can I just introduce my colleague here, Omar Manaf? He hasn't said anything yet, but he's here if you had any very nasty technical questions specifically to the Viking Age Museum, which is one of the projects that he follows up. So actually what you've been seeing here is actually to his credit, and the contractor, of course.
Thank you, Sten.
Yeah.
You said it all.
Perfect. Thank you very much to all our presenters. Are there any further questions from the jury? In which case, thank you all very much for attending. We hope to see you in further sessions throughout the summit. If the jury could remain in the room for deliberations, and if I could ask everyone else to please leave the room. Thank you very much, presenters.
Thank you for having us.
Thank you very much.
Thank
We'll
you.
see you at the award ceremony.
Bye.
Bye. Thank you.